Good morning, friends. So we are here gathered to start a new subject, which has engineering subject. It is a very well-known subject, which is concrete technology. Just take a quick revision of it, what we have to do, what we have done before in the lectures. First, look at the ordinary concrete. Ordinary concrete is made up of mixing an ingredient or organic materials known as cement with water together with a sand or stone dust and natural stands which may be uncrushed or crushed. What it means? It is a ordinary concrete having four ingredients, basics as we know: a cement, a fine aggregate, coarse aggregate and water. In a moderate concrete, there is extra adhesives are used, which may be a chemical admixtures or a mineral admixtures. We come to this at something next beginning lectures. For now, it is fine. For the 6 compound material, these are the compounds of the material used above the admixture together. These admixtures are used. Just we are going to look into the next lecture, but if you recall, the chemical admixture used for the specific performance to enhance the specific property and specific performance. In the mineral admixtures, they are used for improvement for long-term strength and durability performance. What are the advantages of concrete? Why we use concrete in such a big content? Because after water in earth, the consumption material is nothing but a cement, and the best thing about that, the India is the second most creator of cement. Look at some advantages of the concrete. Concrete give a lower life cycle cost, very low maintenance as compared to other construction materials. It has more molding ability, take any kind of shape, takes an ability to go in any kind of shape, or we can say molding ability is very high. Robustness. What is exactly mean robustness? Robustness means nothing but it provides an resistance against to slip. If it is a earth retaining wall, then the resistance offered by the concrete is very high. It's not easy to slip concrete on a soil or any surface which on it lie. So that is nothing but the robustness property. Desired properties can be of low tensile strength, there are some disadvantages of concrete also. With the advantages, the disadvantages are very low tensile strength. In a 456 2000 IS, you ignore the tensile strength of concrete. So the low tensile strength, we look upon that after some lectures. After that, the lower durability is again a problem. Lower ductility, I'm correcting it. A lower ductility is also a problem. Ductility here, it is in the sense that concrete doesn't give any dictation while it is going to be failure. In such steel, we look before crushing or before failure in a steel, it gives that scary appearance. It bulks, it elongates. That is nothing but ductility. It gives us an idea of how it is going to be failure. The next, there are many types of concrete, such as normal strength concrete, high strength performance concrete, ultra high strength concrete, fiber reinforcement concrete, densified with small particles DSP concrete, micro defect free concrete, reactive power concrete, a polymer concrete, self-compacting concrete, roller type of concrete. Look into here in this figure. This axis denotes the binder, this is reinforcement, and this is the matrix, the type of matrix. Such time the matrix are of a cement, such time it's a polymer, such time it may be anything which binds the materials together. It's not be necessary it always be the cement. That is the matrix. And bander is that what I say, anything. And the matrix reinforcement, it's very important. It may be a fiber, it may be a steel, or it may be a glass. Steel we are going to use in a RCC structures, lime and silica. Just quick revision of the types of concrete: normal strength concrete, high strength concrete, ultra high strength concrete. These are the concretes we look upon that up to the lectures. We are just going through the introduction of the subject. Okay, for the lime and silica, these are the main component: lime, silica. As we look up today, we can understand it, but just look what is lime and how it is formed while we are going to construct and manufacturing the concrete. The first use: a lime as a construction material may be a date book to be prehistory time as a predicted. Lime is using so far BC. It is very difficult to even predict at what time we are going to use the lime at first as a construction. But lime and volcanic ash was used in Roman times. There are we have proofs that Roman used lime and volcanic ash togetherly as a construction material. In India, we are looking lime and surkhi. They are basically used and very long ago, not now. The surkhi and lime, which forms a very hard rock with water. Surkhi with lime, they are going to be used in a construction of material. Volcanic ash, surkhi is nothing but it is a basic. If we in clinkers of a brick, we burn the clinks, and there are the residues of a soil which having silica content. After the heated, they are still on the ground, which are not which having high content of silica, and they are burned at a very high temperature. So they have the silica amount, and the silica with water and lime produces a hard mass like a stone. So that is very important. Note down, please. With silica content, surkhi, and with lime and water, they forms a very hard mass, which is very essential. From that, if we look to the origin of cement, it forms from that. It's a clay. Surkhi is nothing but the clay, essentially having silica alumina content, formation from the amorphous silica. Hard material. Cement, most commonly used cement is called the Portland cement, because it is founded in a Portland in England by the very well-known scientist. So having the place name Portland, so Portland is the stone. The first cement produced by the scientist was looking like the Portland, which is the type of stone in England. So they give the name of cement to the Portland cement in 1824. The basic how the material is used in the main factors of the cement are calcium carbonate. The main component of the cement concrete is the calcium carbonate, found as a lime in or chalk, and silica, alumina, and iron oxide found in a clay or shell. The manufacturing of cement, there are two mainly processes. There are a wet process for the manufacturing of cement and a dry process for the manufacturing of cement. The wet process mainly used very long ago, where there is an air compressed situation is not maybe involved. The scientists or the machineries are not that much of high elaborative. They can form. But with the wet process, what we get the best homogeneity with the expense of energy. You can also get the feeling like that if you are adding admixtures, if you are adding the basic components of some material with water and then you are heating it. It consumes a lot of energy as compared to you can mix the components of our ingredients of the cement in a dry process. Later we see how we do a dry processing or wet processing. Look at such advantages of the wet process. Wet process means better homogeneity. In a modern practice, we also definitely grow with the dry process. The grinding depends on the materials and fineness typically. How is the raw material come with us, which depends on how do we grind them. Typically 10 to 30% retained on the 90 micron sieve material we use. Homogenized raw meal is introduced. Here is a formation of process how we manufacture cement. First, limestone is taken from its quarry. Similarly, clay and shell, which contains iron oxide, alumina and silica. They also grinded and blended, and they stored and then blended and then preheated by the cyclone or cyclic heated at a 400 degrees Celsius to the 1500 degrees Celsius, and finally they are going to be added with the gypsum and finally graded. As we look here in this diagram, the raw filling is here, and after that free water is going to be evaporate. After some time the temperature is also going to change in this axis. With that, the decomposition of limestone happens, formation of C3S, formation of C2S. We later on look upon this, what is C3S and C2S. Cement is produced by burning calcium carbonate found in a limestone or chalk, and silica, alumina and iron oxide found in a clay and shell at about 1500 degrees Celsius. The materials center and properly fused together to form clinkers. Or what are these clinkers? Clinkers are nothing but they are just small balls. They are small balls with the water present in there. After heating at a very high temperature, their water is in between them is going to be evaporate, but they are still in the form of small balls. We have to grind them in appropriate size and shape, then we can get very soft material of cement. The clinker is cooled and grinded to the fine powder and to form ordinary Portland cement. There are several oxide compositions. Oxide compositions in a cement are as follows: CaO, which is lime, which is a major component, which is 60 to 67% present in cement as a binder. After that, silicon dioxide, which have 17 to 25% in a cement. After that, aluminium trioxide having 3 to 8% in it. Ferrous trioxide, which is we are known as iron trioxide, Fe2O3, which have 0.5 to 6%, MgO 0.1 to 4%, alkalis 0.2 to 13%. These oxides have their own properties and the what we can say, they have their own benefits for the ingredients, how they react, how they combine, how they behave with the materials, and that going to create a very homogeneous and very efficient concrete. The abbreviative forms, these are always we have to use these compounds at many of the times, so it is not possible to get always go through the chemical formula. So we get some abbreviatives of this, and we always going with these abbreviatives as for the sake of easiness. It is very difficult to always say SiO2 of 17 to 25%. So for the easiness of sake, we always say as a silica S. So these are abbreviations: calcium oxide as a calcium C, SiO2 as S, Al2O3 as A, Fe2O3 as only F. These are important. You have to be noted. You must have to be remember these 4 or 6 components of abbreviation, because we are going to use it at many of the times in our forward lectures. So you must have to be remember this. 3CaO SiO2 is nothing but tricalcium silica oxide, which is known as C3S, abbreviative in the form C2S, C3A, and similarly as you can see. After that, main components in the Portland cement are oxide. After that, we not going to use the name of tricalcium silicate. For the sake of easiness, we say that is alite, belite, aluminate and ferrite. Alite is nothing but tricalcium silicate. Belite is nothing but dicalcium silicate. Aluminate is nothing but tricalcium aluminate. And tricalcium aluminate ferrite is nothing but ferrite. Abbreviations are as follows: C3S, C2S, C3A and C4AF, as you show here. And now we are here to the very interesting topic in concrete technology. Many of you heard about the hydration of water in a crystallization. What exactly means the hydration? Hydration in general, it is nothing but it is a chemical reaction which present in the presence of water. Any chemical reaction which is in the presence of water is known as a hydration. In concrete technology, what is the hydration of water? Hydration process and water of crystallization. These are two things we are looking up to it. In concrete technology, we define hydration as a strength gaining chemical procedure. By this process, cement gain its strength to bind the materials. How exactly it follows? Hydrates are salts compound associated with water and crystallization. Some anions are too large compared to the size available cations, such that the packing efficiency of the compound will not come within the range required for the stability. Packing density is nothing but volume of solids to the total volume. So, the water which is required for the complete hydration process, we are going to calculate it, but these are the reactions which are involved in the hydration. In a very detailed manner, hydration we are going to look into some other time, but we look on a quick revision. What is the hydration process exactly? Hydration of water is chemical bound in a structure and therefore not available for the process such as a fungal growth. It is the water available for the structural elements present in the cement. It is not free water that after some time maybe the fungal infection going to happen with the cement and concrete. Basically, in hydration, what happens, there are several compounds that C3S, C2S, Al2O3, Fe2O3. These compounds react together in several manner with the time for the appropriate temperature, and they form the gel-like structure which is known as CSH gel. And it is not the exact chemical formula for the compound. It is just for the sake of easiness we write it as a CSH. It is a very complicated formula with such variables, depend on the temperature, depend on the atmosphere, depend on the wind velocity, depend on the type of admixture, depend on the type of component and pozzolanic admixture, mineral admixture. It varies and there are several variables present in that formula. So ignoring that formula for the easiness, we write it as a CSH gel. It is a gel-like structure formed after the hydration process and which gives the property to the cement to hold its ingredients tightly. Is it okay? If you don't understand, please pause your video and record this. These are the monosulfoaluminate. Very difficult to understand for newcomers, but after that you can understand. Why gypsum is going to add in cement? Because to avoid the quick setting of cement, we are going to look upon into it in a detail after some time, but just for the rememberation, gypsum is going to add in a concrete cement manufacturing process to avoid the quick setting of ingredients. Majority for alumina, Al2O4. After that, the addition of water, hydration of physical changes. Look at the structure. While going to be the hydration process, these are the physical changes going to be happen in a cement. These are the CHS cell form. These are the capillaries present in a cement mortar. There are free space available in a cement concrete. There are pores which must not be present there, but there are capillary pores, density. This is CHS gel. Outer product is CSH. Underhydrated cement, capillary pores. You can look upon into this graph as x-axis it is the time, on y-axis the hydration process going on, the formation of products, decomposition of lime, and these products are going to be formed in CHS paste is formed in its time, hardening. You can look upon into this Between the initial setting time, there is a CHS gel is formed. After that, there is a low CS gel. The early strength is given to the concrete is due to of the C2S component, C3S component, and the long term strength is given by the C2S component. Bonding action. Bonding action is nothing but the how to bind cement to its ingredient. Now we are going to look on the outline of the strike is this lecture. What we are going to do is the bonding action, heat of hydration, and compound contributing to the strength, degree of hydration, hydrate paste, structural modules, and porosity. We are going to look upon it. Heat of hydration. How the heat of hydration changes with time. Initially, if you look in a minute, the initial strength is given by C3S, because in C3S in early 28 days the majority of its strength, which is 92% of its strength of concrete gains. With increase in time, concrete gains its strength. It means after a 30 year the strength of concrete may be high as compared to 28 days, 3 months or 1 year. With the time, the strength of concrete increases. Many of you don't know about it, but it is true. Degree of hydration. Degree of hydration is nothing but is a fraction of mass hydrated at any time. Hydrated at any time, it means it do its reaction, provide the strength to the concrete. There are structure of CSS gel. These are the structures by the various scientists by their countries. How they just imagine how the structure of a CSS gel must be look into concrete, and they put their theories according to that their research, and these are yours. You can look upon into it. These are the CSS gel formation. These are the inner particle bond. Adsorbed water is there. These are the structure of a CSS gel. These are capillary pores which are maybe filled, how it is going to be filled, how the density of a concrete depends on what are that factors. We are going to look upon it also. There are pores in a paste.